Okay, I think everybody should be here now and we can start with the webinar. I welcome everybody to this webinar about node and edge annotations in graph layouts. My name is Benjamin Niedermann. I'm a software developer at yWorks and a member of the layout algorithms group. So this basically means that I work on layout algorithms on a daily basis. So I improve the features of these layout algorithms. I implement also new ideas and features for these algorithms, but I also develop new visualization techniques that you can use to visualize your connected data. Besides that, I also do this series of webinars, and the idea of these webinars is that I introduce you to the layouts offered by the yFiles library so that you can use to visualize network data and graph data. The idea of a single webinar is that I present one particular layout, and in this webinar I then answer questions like how to use these layouts and when to use these layouts. Today is a bit of a special webinar because it's not about a particular layout algorithm, but about a topic that connects all these layouts, namely about labeling, so annotating graphs with edge and node labels to introduce further information and to give some context for these nodes. So why doing an entire webinar about this topic? Why is this important? And I would like to motivate this with the following example. So let's have a look at this layout. Obviously, this is a layout or graph layout of a metro system, so of a transportation network, or more general, of a geographical network. And as usual, or often done, these metro systems are drawn in a schematic way. So this basically means that we only use a subset of directions, namely horizontal, vertical directions, and diagonal directions. From a graph drawing point of view, this is a really nice drawing. It only has few bends, and it simplifies the geographic transportation network so that you can easily conceive the information and the network information of this graph. So it's really easy to see how to get from this node to this node. However, in real life, you won't be able to use this map. So assume that you are standing at a station, let's say at station A, and you would like to go to station B. Then it will be really problematic using this map if you don't know the entire system by heart. So what is missing is that we haven't placed any labels. And this is really important for graph drawings, that you bring in also some other context, for example, by annotating nodes and edges with further labels. So for a metro system, typically what we do is that we label the stations with their names, and this is basically the most important information for metro systems, for example. But we, of course, can also add further information like the traveling time. Considering other examples, so from other use cases, you will probably introduce other attributes and other information that you would like to annotate to your nodes and edges. And this webinar today will be about how to do this and how to create a good placement for the labels and how to annotate edges and nodes. And I will structure this webinar as follows. In the first part, I will describe and present some general principles about placing labels in graph layouts. Then in the second part, I will talk about label placement in practice, so especially taking a perspective on yFiles, so the library that you can use to visualize your data. And then in this third part, I will also present a short demo for one particular labeling algorithm, so that you can also try out on our homepage. And then in the last part, I will present a coding example showing you in yFiles HTML how to actually use such labeling algorithms in yFiles. At this point, I would like to mention that if you have some questions, then just leave them in the chat. And after this main part of the webinar, there will be also a Q&A session in which I will then answer these questions. In case that you watch this video on YouTube, because we also will upload this on YouTube, then you can also just leave these questions in the comment section and we will try to answer them as soon as possible. Alternatively, you can also, of course, write some email. So with this, I would like to start with the main part and with the principles of labeling. And I would like to start with a very general question, namely what can be labeled in a graph layout? And the answer is rather simple, namely everything. But of course there are some items or elements in this graph layout that are typically labeled. So one important item or element is, of course, are the nodes, where we can place the labels. So what we can do, for example, is to place the label outside of the node, or we can place it inside. We can also use images to place or to as labels. So there are many different possibilities. The next element that we can label are the edges. So here we have some decision node and we have labeled these possible decisions, so yes and no, with these labels. And then there are, of course, even more specific elements, for example, these ports that we can also label so that the labels are really close to this node or to this port of this edge. And then what we, of course, also could label or annotate is the background of this graph layout. In this case, the swimming lanes. So for example, here we can place the labels in the headers of the swimming lanes using, for example, vertical lines. So this gives you a first impression what you can do or how you can annotate a graph layout. And in the next on the next few slides, I would like to give you some more impressions on this, showing you some examples and some use cases. The first example is a hierarchical layout. So this layout has been created with the yFiles hierarchical layout. And here we have decided to place the node labels inside of the nodes, and also we have used horizontal labels. And then we have placed these edge labels besides the edge, also using horizontal labels. This is a typical decision, and often you can see this in technical diagrams. Placing the node labels inside in the interior of the nodes can be really helpful, for example, for the layout algorithms, because then we only need to take care about the node but not the labels. But on the other hand, of even more, what's also important is that placing these labels in the interior of the nodes also creates a really strong visual connection between the label and the node. So for this label here, it's rather clear that it belongs to the blue node, and no one would say, okay, this label could belong to another node. So this visual connection is really strong. On the other hand side, this also requires that the node becomes really large. And depending on the layout, the node may become too large. Here's another example where we also used a hierarchical layout, but this time from left to right. And again, we placed some of the labels inside of the node, but also other labels in the exterior of the node. And here the idea was to place labels that describe the role of the node inside or in the interior of the node, and more additional information. So for example, the costs of these processes, for example, outside of the node. So here we have used this decision between interior and exterior labels to also express different types of information. Furthermore, we also have used edges along edge labels along the edges, again just using horizontal labels. Of course, we are not restricted to horizontal labels, but we can also use other labels. So for example, vertical labels. Here again, we have used a hierarchical layout. This is a graph drawing that you can also find on our webpage. It shows the Marvel universe. And if you would like to, you can explore this interactively on our webpage. Here we have used vertical labels. So what you can observe in this layout, it's a really long layout. So it has a really large width, and for this we here decided to use vertical labels in order to fit in them into the layout. I can also magnify this a bit. Here you can see them. What we also did, we used some icons for other labels. Another thing that we did at this point is that we also used different type of font sizes, for example, to express the importance of certain things. The next example is a cactus layout that you can also produce with the yFiles library. Here we used both horizontal and radial labels, so we do not only need to, we can also use labels that have an arbitrary rotation, and here the idea is that the labels point towards the center of their nodes. And this really blends in with the remaining layout. So here we have a kind of tree structure which goes from the center to the outside, and these labels at the leaf nodes basically support this kind of layout, so that you have this impression that they blend in with the remaining layout. For the internal nodes, we have used internal labels. These nodes are typically a bit larger and can also take these labels, so there is enough space for them. We also decided to use different font sizes in order to express the importance of the node, or how close it is to the center of the root node, or how close it is to the root node of this tree structure. And of course, we can also create radial layouts, or layouts where we only use radial labels. Here, for example, we have a circular layout where we only use these radial labels pointing all to the common or common center of these circles where we place the nodes on. Here, the idea is, again, it's a really large graph. As you can see here, it's the tree of life. You can also explore this on our demo web page. And there are many, many nodes. So if you assume that each of these nodes would have a horizontal label, but still using this kind of radial layout, then it would become really cluttered. So we decided, okay, it's better to somehow support this graph layout by also using similar directions for the labels. And finally, I would like to show you also another example, an interactive example that you can also find on our webpage, namely the Wonderlands. And here the idea is that you can use a lens to explore a graph. And before I say too much about this, I would like to go to this webpage and show you this live. One moment. So what you can see here is a graph layout, or a graph showing criminal cases, and there are different types of nodes which we express with different icons. And this graph is rather large, so we only show a very small portion. So we don't show the entire graph because this would be too much information. But what you can now do is to use a lens to explore this small portion, and then based on this exploration you can decide how to extend this graph further. And here the idea is that you can move around this lens, for example, to this group of people here, and then you can see all the names of these persons. And the idea is that the labels are not placed inside of the lens, but outside of the lens, so that you can still see the structure of this graph inside of the lens, but still you get a lot of information. And in order to create this visual connection, we use straight line segments to connect the labels with the nodes. So if I just drop this lens at some point, for example here, one moment, the screen is a bit small. Now it works here. For this case, you can see that dropping this lens, what happens is that we even get further information. And what we can do at this point is that we say, okay, we would like to expand this graph at this node by clicking on this, and then the graph expands. And this procedure you can use to basically explore the graph. And here it's also very important to have labels to get further information. But this time we decided not to show them at once for the entire graph, because this would clutter the graph and make it not legible anymore, but we decided to show only a subset of labels. And with this example, I would like to end this sequence of examples where I wanted to show you some, or give you some impressions what you can do with the labels. And now in the next part, I would like to summarize these observations, discussing two main aspects of label placement and annotating graph layouts. And these two main aspects are styling, so how you can actually style a single label, and then the second aspect is the placement, so the idea where to position the label and how to position the label. And I would like to start with the styling. So obviously for the styling there are many different options, and so for example you can change the fonts and formatting, you can change the color, or you can decide between image and text, or you can even combine them, but you can also use different shapes and sizes. Fonts and formatting is a really important topic, because you can express different types of information. So if you, for example, use bold font type, then this typically tells you, okay, this is an important information. The same holds for the size of the font. So if you use different text sizes for the note labels, for example, you will express different importances for this. With the color, you can also express a lot of different types of information. A typical thing is that you, for example, could use the same background color as for the note. So this will enhance this visual connection between notes and labels. But you can also use the colors to categorize information, so that you say, okay, I have certain types of information and each type gets an own color. And the next thing is that you can also support the information using further elements like images, so you can introduce icons. Sometimes it pays off only to use icons, but sometimes you need to explain some things, but then the textual explanation can be shorter because the icons already tell you a lot of things. And then finally, the shape and size. Here the idea is again that they can express importance of information, but also categories of information. So here, for example, this diamond shape you can, for example, use for another type of information, as, for example, this label with rounded corners. At this point, I would like to say some kind of warning, because it gives the styling of labels gives you a lot of possibilities, but it's always important to be consistent. So, and not to overuse these concepts. So, for example, if you use colors, you should decide on a small set of different colors, so that you still can perceive this and understand this easily as the viewer of this graph layout. And the same also applies for the shapes and sizes and for fonts and formatting. So you should always try to be consistent and to reduce the choices only on a small set, to express only the most important things about this. The next aspect that I would like to discuss is the placement of the labels. This is also a very important topic, because if you have assume you have some graph layout, and this is maybe a really nice graph layout, and then you just place the labels somehow on this graph layout, then what you will get is a cluttered graph layout, and you basically have destroyed this this graph layout. So it's really important to also think about this placement of the labels. And here I would like to discuss 4 aspects, namely position, rotation, the overlap between labels, and the visual association. So first of all, the position. I already said this several times in the example part. There is one main choice that you can do for nodes, for example, namely whether you place the labels internally, like here, inside of the node, or externally outside of the node. If you place the labels outside of the node, what happens is that you can make the node a bit smaller, and you can really use this space here around this node. So sometimes this gives you the possibility to make your layouts even a bit more compact. On the other hand side, you can also use internal labels to express a very strong visual connection, or to express the most important information for this node, for example. In both cases, you further need to decide where to place the labels, and this is a rather difficult decision sometimes. So for example, you could say, okay, I also always want to place the label above the node, or maybe on the left-hand side, and depending on the type of information, you can choose different types of positions, of course. The next thing I also mentioned in the examples is the rotation. So here I just gave 2 examples, namely for vertical labels and horizontal labels. But as you also have seen in the examples, we can also use different angles for this. Here it's really clear that horizontal labels are the most legible elements or labels that you can place, because we are used to read horizontal text. So vertical text becomes a bit more difficult, and so if you use a label with 45 degree, this is somehow between vertical labels and horizontal labels concerning the legibility. So here again, you need to balance this between legibility and sometimes whether this blends in with the layout, or whether it saves you some space so that your layout can become more compact. The next aspect is the overlaps between labels. Here it's important to say that overlaps you should really avoid if possible. Sometimes this is not possible, then you need to reduce them as good as possible. But if you have overlaps, you need to think about this, that the parts of the overlapping parts won't be legible anymore. You can improve on this, of course, if you use a background. So then in that case, one label is hidden behind the other, so at least one is still legible and the other is not legible anymore. But of course, if it is possible, you should try to position them such that they do not overlap. And later on, you will see that you can also do this automatically with the yFiles. And then the last thing, but also really important, is the visual association, so the visual connection between label and the elements that are labeled. So in this case, this red label is not clearly connected to one element. So it could be the label of this red node to the left, but it could be also the label of the red node to the right. But even more, it could be also the label of this edge, and it's just not clear. And the reason is that it has a similar proximity to all of these 3 elements. So what you can do is that you can basically place these labels a bit further away from the other elements, so that the proximity, so the distance to their elements, it's much smaller than to other elements, and then the visual connection becomes clear. Another possibility is to use connection lines, like you have seen in the interactive example with this lens that I've shown before. And with this, I would like to go to the next part, namely to how to do this in practice. So or what possibilities do you have, for example, in our yFiles library to place labels for edges and nodes? And in this part, I would like to basically focus on the placement and not the styling. In the coding example later on, I will also talk a bit about the styling, but here it will be mostly about the placement. So let's start again with a question, namely how to describe the position of labels. So this is a really fundamental question, because if you want to tell the algorithms, for example, that they should place the labels for you, then you should also have a possibility to describe your preferred positions that you would like to have for the labels. And there are basically two types of models how you can describe this in yFiles. Namely, there are these free label models that basically use offsets and angles and ratios to describe the positions of the labels. And then on the other hand side, there are also these candidate-based models where you can describe valid positions, so sets of positions, like you can see here in this image. And I would like to first discuss the free label models a bit more in detail. So these are three examples. There are more label models in the yFiles library, but I think if you understand these three types of models, then it's also easy to understand these other models that you can use. The most general model is the free label model. Here the idea is that we describe the position of a label relatively to the origin of the global or of the world coordinate system. So if we have a label, for example, for a node, we don't care about the node, but we describe the position with respect to the global origin. And we do this in the following way. So what we do is we describe basically this vector here and then also this rotation angle. And what I haven't depicted in this drawing to keep it a bit more simple is that you can also decide basically on the rotation point of this label, so that you don't need to rotate about around this corner here, but maybe also around other corners. For the free node label model, we use a very similar concept, but this time it's the label position is described relatively to the node, namely to the top left corner of the node. And the idea is that based on this top left corner, we define a reference point based on the ratios in x and y direction. So for this example, I've used an x ratio of 0.5, saying basically that this reference point should always lie in the middle of this top segment. And then I also used a ratio of 0, which I haven't depicted here, for the y coordinate, telling that I want to use the top edge. So if I would like to use the bottom edge for this reference point, I just could say, okay, the ratio, the y ratio should be 1.0, saying, okay, it should be at the bottom side of this node. So these ratios allow you to describe relative positions to this reference point at the top left corner of the node. Then further, what we can also do is describe some offsets. So again, some vector describing where to go from this reference point, and in this case we go to this point, and then we can again define some ratios also relatively to the top left corner of the label to describe this point with respect to the label. And then we can, so that we say, okay, we would like to rotate the label around the bottom left corner using the angle alpha here. And finally, so this is basically a very simple way, or a very simple geometric way to describe the label text position relatively to the node. And for the edge, we do it's very similarly. Here we use a ratio of 0.5, for example. Of course, you can customize this to say that the reference point should be in the middle of this edge, and then we go orthogonally away from this edge, and then we also can rotate this label. And this is a way how we can describe the position of the labels. As I already said, this is not the only possibility, but there are also candidate-based models which are often also used because often you just want to place labels, for example, in the eastern part of the node or in the western part, and then you can specify this very easily. And here again, yFiles offers you a lot of different possibilities how to do this. There are some typical examples. So for example, this exterior label model, which defines 8 positions in the exterior of the node. The interior label model, here the idea is that you can place the nodes inside of this node, and then there's an additional position, namely the center node. And then there are 2 other label models and even more in the yFiles library. So if you're interested in seeing how these work, I refer you to the documentation for this. For edges, and we have also multiple models, and one of them is the 9-position edge label model. Here the idea is that we have these positions which are either close to the source of the edge or close to the target of the edge or at the center of the edge. Especially for UML diagrams, for example, you can often see this, that you use different labels at a different position, so that for an association you can say, okay, this label is placed at, or the meaning of the edge is placed here at the center, and then other information is placed at the source or at the target. And of course, as I already said at the beginning, we can also label the background of the graph layout. So for example, swim lanes, and also for this we have candidate models. So this was a lot about models, and now the question is, how can we use them in a concrete case? And this is the next thing that I would like to discuss. How can we specify the placement? And basically there are 2 main options in yFiles. The first option is that we specify the placement for each label. Sometimes we just know where we want to place the label, and then we can just specify this using the label models, defining them. On the other hand side, sometimes we don't know this, and sometimes we don't want to think about this, but we would like to do this automatically. And for this, you can use automatic approaches for label placement. So first of all, about specifying the placement for each label. Here the idea is that for free or here I give just 2 examples. One example for the free label model, and then one example for the candidate model. And for the free label model, what we basically do is we describe these parameters that I've described before. That you can see here in this very small coding example. What I do here is I create a label for a node with a text label text, and then I also create a label model which is called free node label model here in this case, and then I define different parameters. So for example, the layout ratio is here this 0.5 for the x direction and 0 for the y direction. And then I also define some layout offset. This is this part here. So the angle I haven't mentioned here in this example, but what I also did, I defined the label ratio. So as I already said, here is also a reference point, and now I go downwards, namely the entire edge or side of the label, and then I place this rotation point here at this point. And then what I do is I use these parameters to define a label parameter, or to create a parameter based on this model. And this parameter I can attach to this label here. And then the graph knows where to place the labels, because now we have described this position exactly. And there's a reason why we don't do this directly, so that we don't pass this model here, for example, directly and could configure this model. The idea is that you can reuse this parameter so that you can say, okay, this is a very general description that does not only suit one label but many labels. And what you can do is that you can set this parameter for multiple labels or for arbitrary many labels. So you can reuse this information. For candidate-based models, you can do basically the very same, but here it's a bit simpler because the possibilities, so the number of choices that you can do is a bit smaller. So for example, here I used the exterior label model, and for this exterior label model I created a parameter based on the decision that I would like to place the node in the southern part of this node here. And then I just say, or I tell the graph that it should place the label at this position. And again, I can reuse this parameter not only for this label, but for many other labels again. So this is how you can specify the placement for each label, and sometimes you know how to do this. For example, for edge labels, you sometimes know that you really want to place the labels at the center of the edge, then you can use, for example, this method. But sometimes you don't want to decide on your own how to do this, or there are multiple positions where the label could be, and all of them are basically okay. And then it's better to optimize this, so for example, avoiding overlaps. And this is the second option, namely that you can use automatic placement approaches. And here you can use two different ways in yFiles. The one way is that you use integrated labeling approaches in layouts, and the other is that you use in standalone labeling. So for these integrated labeling in layouts, the idea is that the layout algorithms typically already know how to place labels, so this depends also on the style. Here in this cactus layout, for example, we know that for the internal nodes we want to place them horizontally and all others are placed radially. And this can be done by the cactus layout by its own. And of course you can also configure this, you can also describe other possibilities, but this is just done by the layout algorithm. And the similar applies also for other layout algorithms. And if you are interested in this a bit more, then I refer you to the other webinars that you can already find on YouTube, where I discuss each of these layout algorithms by itself, and there I also typically discuss the labeling problems a bit. So now I would like to focus on the idea of a standalone labeling. Here the idea is that you are already given a layout, so for example here this metro map, but maybe you have some other layout created by the hierarchical layout algorithm, and then you would like to place the labels in a post-processing step. And here you can apply the generic labeling algorithm to place these labels. So here it's important to say that the layout of the graph is not influenced by the label placement. I would like to shortly describe how the generic labeling works, because then it's easier to also apply it in practice. So the idea is that we are given a fixed layout, here with these 5 nodes, for example, and the generic labeling just creates a lot of label candidates. For each node it creates many candidates, and if you also consider edge label, it does the same also for the edges. And then in the second step, using some optimization approaches, it selects the label candidates for the node. So in this case, I only have one label per node, so it selects one label candidate for each node, and then the labels are placed based on these label candidates. And here this optimization approach optimizes, so for example, the overlaps with edges or the overlaps with other labels, or also with nodes. And even more optimization criteria can be taken into account. The nice thing is that you don't need to care about this too much, because there is already some implementation in yFiles that you can use. So then you don't need to think about how to do this optimization too much, but you only need to configure this for your purposes. So typical or important features of this approach is that it supports both candidate-based and free label models. So when you use a candidate-based model, it will create label candidates based on this model. So for example, for the 8 position model, it would create here 8 labels around this node. You can also use free label models. In that case, it will create a really large bunch of candidates that will be placed around this node. As typically it creates more label candidates for free label models than for candidate-based models. We recommend often to use free label models if you don't care too much about the positions of the labels. So if it's also okay to place this label a bit higher or lower, then the layout algorithms get more possibilities if you use the free label model to decide on this. And then this typically produces maybe label annotations with less overlaps. Further, I would like also to mention that they are also restrictable to subsets of labels. So what you can also do is that you can apply this generic labeling algorithm only to few nodes. This can be interesting, especially in the interactive case. So if you move some of the nodes, then you only want to change maybe the labeling or the label placement for the labels of these nodes and not for the entire graph. And before I tell you too much about this generic labeling algorithm, I would like to go to the demo and show you this just using it. And for this, I will go to the web page. You can also have an own look at this example or this demo that you can find on this URL. And now I will go to this page and will show shortly how to use the generic labeling. So this demo is about the layout styles that you can use in yFiles, and there's one option, namely that you can see here the labeling layout or the labeling algorithm, and I use this metro map. And here you can play around with these options, and typically they directly map to the options that you also have in the API. So what you can do here, for example, is to decide whether only to place node labels or edge labels, and you can also decide where to place the labels. So for example, I could say I want to place these edge labels at the source. And what now happens is that the labels here move to the source of the edges and are not placed at the center. So here I go back to the center, or I just use anywhere. When I use anywhere, it basically creates a set of candidates for each edge and then chooses the best based on some optimization criteria. Of course, I can also change parameters like the distance to the labeled object, but what I also can do, I can say, okay, it should only consider a selected feature set. So for example, assume that I have changed this labels here and I only want to relabel this node but not this node here. I could select this and say, okay, I only want to do this for this single node, and then this labeling will be prepared for this node. And of course you can do this also using or from a programmatic view, so you can use the API to basically define this. So especially in an interactive scenario, this is rather helpful. So if you would like to see more about how to configure this generic algorithm, I recommend you to go just to this demo page and to play around with this. But also, of course, in our documentation, you will find a lot of information about this. And with this, I would like to go back to the presentation and jump to the next part, namely the coding example. And this will be only in short coding example where I use yFiles HTML. If you come from another platform, so for example from .NET or Java, which is also supported by the yFiles library, this is no real problem because the API is basically the very same, and you can also understand what I will do in the yFiles HTML example. So I will reduce this basically to the layout code. And so I will show the following example. The idea is that I create a label placement, as you can see here, for the metro map, and will describe how to configure this layout algorithm. To that end, I go to the coding example now. I just rearrange my windows a bit. And this is the input. So as you can see, the labels are not placed. They are just placed at the center. They already have some styling, and later on at the end of this coding example I will also explain how I did this styling in the code, in the source code, but I also will explain a bit why I have chosen this styling. So what I have here in the source code is this method, which is empty, and it's called place labels, and it's called when I load this graph, and then I can place these labels. And now I can place the labels step by step, and the first thing that I would like to do is to place the edge labels. So the node labels will remain in the center, but I will only place the edge labels using labeling models or the label models. And to that end, I create an label model, an edge label model, and what I do is I use a smart edge label model. So I haven't presented this in the slides before, but the idea is that this smart edge label model also changes the labels when you, for example, move some nodes and changes the edge. So it reacts smartly on changes. And then what I do is that I use a parameter in order to describe or to say that the edge labels should use this label model. And for this I use this edge label model and say I can just use the default parameter, but what I also can do is I could use a parameter describing the position relatively to the target. Here the idea is that I can, for example, describe the number of segment where I would like to place this label, and then also where to place it on the segment. But this time I would just want to use the default parameter, which basically will place the edge label on the center of the edge. And then what I can do is that I go through the edge labels of the graph, and for each of these edge labels I will set the parameter. And this I can do this by setting or calling the set label layout parameter function or method. And here I just pass the label as parameter and the parameter, and yeah, I should use a lambda function. And so this lambda function, so this for each of course expects a lambda function, which then has a label as parameter, so on one of these edge labels, and for each of these labels I set this parameter. So here it's also important to say that I reuse this parameter, which also saves some storage. And restarting this demo, what now happens is that the labels are placed along these edges, and what I can also do is I can move these edges a bit around, and the labels will also move. As you can see, this stop, the name of this stop also moves, of course, and this isn't placed very nicely, so this will be the next part what I will do. And for that I won't use a label model directly, so defining any parameters, but this time I would like to use the generic labeling approach. And to that end I just define, or I just create an instance of the generic labeling algorithm. and then I can also apply this on the graph. And what I also should say is that I don't want to label or place the labels of the edges. Actually, as I do this beforehand, before I do this, it wouldn't be a problem. This would just override the positions of the edge labels, but we don't need to consider them here, so I just tell the algorithm it should not consider them. And the property is called place edge labels, and I say just false. And placing node labels should be the default, that it should be done this. So now I've just created a generic labeling, and what it has done is it has created a lot of candidates, and based on these candidates it has chosen some positions for these labels, and now we get this positioning here. We can of course use different optimization criteria. So for example, we can define here this optimization criteria, and for example we could say it should somehow avoid edge overlaps, but we could also say we are really eager in avoiding label overlaps, but there are also other optimization criteria. And now what I can do is I can specify the positions of these labels a bit further. So looking at this placement, what we can see here is that we have many switches between the labels. So there are some labels on the left-hand side, then on the right-hand side. Here, for example, again. So it would be nicer to have this label on the right-hand side than on the left-hand side, just for consistency, for visual consistency. And this is what we can also describe. And now we can customize our labeling. To that end, I define two models, namely a two-position model that I will use for these intermediate stops here. And then I will also define an 8-position model for the crossings here, because a 2-position model won't be sufficient. There are too many other edges. And then I will also do this for the bends, because the 2-position model just creates 2 candidates per edge, per node, and this is too restrictive for crossings and for sharp bend nodes. So the 2-position model is defined as a discrete node labeling layout model, and we can tell this model which candidates we would like to have. So for example, we can say that we candidate mask, that we would like to define a candidate mask, and for this we can define that we would like to have here I would like to concatenate this. Here I would like to say I would like to place the label in the western part of the node, or in the north part. And the same I can also do here for the 8-position model. And a possibility would be now to also define the other 8 positions, so in the southwest part or in the northwest part and so on, and writing down here 8 constants. But what we can also do is use a predefined constant. And here we can use the 8-position mask. And it's important to say that these are bit masks, so you can just concatenate them using this OR operator. And now what we can do is we can tell the algorithm that we would like to use these 2 types of models for our candidate creation. And to that end, I need to create a layout data. Labeling data it's called. And what I then do is that I tell the layout data that I want to use these label models, and I can specify for each node, for each label an own label model. So this is is again a lambda function, and this is a bit more complicated. So what I do here is, okay, I can do this without. So I check whether the owner of this label, so the node of this label, is a crossing station or a sharp bend, like this. And I check whether this is the case. Now I jumped to a position. One moment. Yeah. So I check this, and in the first case I return the 8 position model, and in the other case I return the 2 position model. So now it should be reformatted so that it becomes readable. So here again, for this label, I decide if its owner is a crossing station or sharp bend, then I use the 8 position model, giving a bit more flexibility. And on all other cases, I want to use a 2 position model. So I restart this again. And what we now, the typical thing that I always miss is that I should add the layout data to the apply layout. Otherwise, the layout algorithm does not know anything about this configuration. So now I can restart this, and now what you can see is that the labels are placed all on the same side, but here I would like to use east, not west, because I would like to place the labels on the right-hand side. So again, now our labels are placed on the right-hand side, and this becomes now more consistent regarding the visual appearance of the labels. What I also can do is I can also define some distances. So for example, I could say, okay, I would like to have a distance of at least of 10 pixels to the node. I can also do this. Here, for example, I could say maybe 5. And then I increase the distance to the nodes. This is basically a very simple example how to use the generic labeling algorithm, and also how to configure it so that it will use different types of candidate sets for the labels. And then you also have seen that you can also define the parameters directly, and using, for example, some kind of edge label model. As I said at the beginning, I also want to talk a bit about how the styling is done. Here for this, I have this style labels method. And what I have done here is that I created different label styles for the different labels. So for the intermediate stops, I created small labels using a small font size of 15 pixels, and here I've used 20 pixels for the large stations, and I also used a background fill with a certain color. And then this is also important, I used an inset so that you have here some distance. Sometimes you see graph layouts where this distance is not used, but I think it looks much nicer having this inset here. And what I do is with these styles is that I go through the node labels, for example, and then deciding, depending on the type of the owner of the label, whether it gets the crossing style or the intermediate stop style. And the same I do for the edge label styles. And this is all what I've done for the styling of the labels. And again, regarding the decision why I've done this, so I used large font sizes for the main stations or for the crossing station because they are important. I also used here colors that have a large contrast to really emphasize them, and then here I only use these small sizes texts to just say, okay, these stations are not that important. And this was basically the coding example, and with this I would like to go back to the presentation. and also come to the conclusion of this webinar. So what you've seen is that label placement or annotations of graph layouts is a really important topic. So having a graph layout, a good graph layout or creating a good graph layout is difficult, but you can do this with yFiles. But it's also important to add additional information, bringing this graph layout into context of your application. And here you have different possibilities to design and style the annotations. So you can do some styling on the single labels, but you can also influence the placement of these labels, and this will also influence the appearance of the overall graph layout. And what you've also have seen is that you have different possibilities to do this in yFiles, namely either to specify the placement for each label, which is sometimes good, for example, if you really know where to place the labels, but sometimes you don't know this and you would like to leave this to someone else, and then you can use the automatic approaches of yFiles. And with this, I would like to conclude the main part of the webinar and go to the Q&A session. In the next minute, I will have a look at the chat and will read through the questions, and then I will come back and will answer these questions. Okay, I think I already have some overview. There are not many questions. The first question is whether it's about the generic labeling, and it's about whether it's possible to rate candidates differently, so that certain candidates are preferred. As I said, the generic labeling creates these large sets of candidates, and yes, it's possible to also influence which of these candidates are chosen. What I've shown you in the webinar is that you can select some optimization strategies. Basically, what they do is that they apply predefined profits models to the candidates, but you can also define your own profit model, so that you can say, okay, for certain label candidates, I really want to have a large gain or given large gain in this optimization strategy, that it's really likely that they are chosen. Only if it's not possible, they are not chosen, maybe due to some overlaps or so. So this is basically possible by doing this, by implementing own profit models, but typically my impression is that it's often sufficient to just use existing optimization strategies, like saying, okay, I would like to avoid edge overlaps. The next question is that here asks someone that says that a graph layout is already given with some placed labels, and the question is whether you can derive the label models from this. So basically that you have these label positions, so the labels are already placed in the layout, and you would like to derive the label models and the label parameters for these particular models. So basically what you need to do is you need to decide on your own on the model, which model you would like to use for describing these label positions. But what you can often do is using the interface iLabel model parameter finder, which has many implementations. So many of the label models also implement this interface, and this you can use to find a label parameter that describes the position best. So it can be that then the position is changed if you apply the parameter, but typically only slightly, because it chooses the best parameter. This is what you can use basically for interactive scenarios, when it's about someone has changed the label position, and now you would like to introduce some small correction so that it fits your label model again. And the last question is whether it's possible to have multiple labels per edge or node. And yes, this is clearly possible and also very important. So for example, for UML diagrams, you need to have often multiple labels for the nodes and for the edges, of course, also. For the edges, I also already gave some example with this association edge. Where you want to place a label at the source and the target, for example, showing multiplicities, and then a center label at the center, and label at the center of the edge describing the meaning of the edge. And this can be done easily using the yFiles library. So what you can do is just add multiple labels, an arbitrary number of labels to the node, and they can have different label models and different label parameters per model. So you are really free to configure this if you want to. Yeah, I think this is the last question. With this, I would like to wrap up the webinar and thank you for your attention. And with this, I finish this and wish you happy diagramming.